You open your browser every day and go to your preferred websites, whether they be for social media, news, or online shopping. By entering a URL or clicking on a link to the page, you can access this page. Have you ever considered what goes on in the background? When you enter the URL and hit enter, how does the news reach you? In what way did the pictures in this article appear in your browser? How are your Twitter feed and tweet data secured when they appear in your browser? In this video, we'll look at what happens when you type a URL into your browser and press enter. End-to-end, the process involves the browser, your computer's operating system, your internet service provider, the server where you host the site, and the services running on that server. It's important to understand where things can go wrong, where to look for performance issues, and ensure you're offering a secure experience for your users. We'll begin by examining the connection between websites, servers, and IP addresses. We'll then go over the actions your browser takes too. Websites are collections of files, often HTML, CSS, JavaScript, and images, that tell your browser how to display the site, images, and data. They need to be accessible to anyone from anywhere at any time, so hosting them on your computer at home isn't scalable or reliable. A powerful external computer connected to the internet, called a server, stores these files. When you point your browser at a URL like https github.com/donishneru, your browser has to figure out which server on the internet is hosting the site. It does this by looking up the domain, github.com, to find the address. Every item connected to the internet has a special address known as an IP address, including servers, smartphones, and your smart refrigerator. 4 numerical components make up an IP address, but numbers like this are hard to remember. That's where domain names come in. github.com is much easier to remember than 140.80 to .112.4, right? Imagine having to remember all the phone numbers of your contacts without having the Contacts app on your phone. Your Contacts app lets you look up phone numbers by name. On the internet, we follow the same procedures. Similar to the Contacts app on our phones is the Domain Name System, or DNS. DNS helps in locating servers on the internet for our browsers and for us. On the basis of the domain in github.com, we may perform a DNS lookup to determine the IP address of the server. Now that you know about the different parts and how they relate to one another, let's look at each step of the process and how the browser communicates with the server when you type in a URL. Whether you typed in a URL or clicked on a linked URL from the current page, the process is the same. If you enjoy watching the video, make sure to hit the like button and subscribe to the channel to show your support. The process: 1. You type https://github.com/donishneru in your browser and press enter. Let's break down the parts of this URL you typed in to get here. Scheme. HTTPS is the scheme. HTTPS stands for Hypertext Transfer Protocol Secure. This protocol instructs the browser to use Transport Layer Security, or TLS, to connect to the server. TLS is an encryption system used to protect online communications. When using HTTPS, your browser and the server transmit encrypted data, such as passwords or credit card numbers. Additionally, you might have seen FTP, Melto, or File. These are additional protocols that browsers are capable of handling. Domain. github.com is the domain name of the site. It is the memorable address and points to a specific server's IP address. Path. Sometimes there is an additional path to the resource in the URL. For example, for this URL, https://github.com/donishneru/harmonicode-donishneru is the path on the server to the requested resource, HarmonyCode. You can think of this as the directory structure of files and other directories on your computer. It's a way to organize your resources, whether they are static HTML, CSS, JavaScript, image files, or dynamically generated content. Common examples of paths are blog, posts, tags, or images. Each grouping has different resources. Resource. When you type this URL into your browser, Harmony code is the resource's name on the website you want to view. Sometimes you'll see this with a file extension, .html, which indicates this is a static file on the server with HTML content. Without an extension, like this URL, it usually indicates the server generated this content. For instance, a news site would show you customized, up-to-date, and local news content, which it can only do when it knows who you are or where the request came from. 2. Browser looks up the IP address for the domain. The browser must determine which internet server to connect to when you type the URL into the address bar and hit enter. To do that, it needs to look up the IP address of the server hosting the website using the domain you typed in. It does this using a DNS lookup. We'll go through the DNS lookup procedure in general, but it's a complicated subject that goes beyond the scope of this video. Because DNS is complex and has to be blazingly fast, DNS data is cached at different layers between your browser and at various places across the internet. Your browser checks its own cache, the operating system cache, a local network cache at your router, and a DNS server cache on your corporate network or your internet service provider ISP. If the browser cannot find the IP address at any of those cache layers, the DNS server on your corporate network or at your ISP does a recursive DNS lookup. A recursive DNS lookup asks multiple DNS servers around the internet, which in turn asks more DNS servers for the DNS record until it is found. Once the browser gets the DNS record with the IP address, it's time for it to find the server on the internet and establish a connection. 3. Browser initiates TCP connection with the server. Transmission Control Protocol, more formally known as TCP, is used throughout the public internet routing infrastructure to route packets from a client browser request through the router, the internet service provider, through an internet exchange to switch ISPs or networks, and finally to find the server with the IP address to connect to. However, this is a terribly inefficient and diversionary route to take to get there. Instead, a lot of websites employ a CDN to cache both static and dynamic material closer to the browser. A CDN is a globally distributed network of caching servers that improve the performance of your site or at the origin by bringing the content closer to your users. Requests from the client browser get to take advantage of this private network that has ultra-low latency and high availability. To track the hops the request takes from my computer to github.com, we can use traceroute. Once the browser finds the server on the internet, it establishes a TCP connection with the server, and if HTTPS is being used, a TLS handshake takes place to secure the communication. 4. Browser sends the HTTP request to the server. Now that the browser is connected to the server, it complies with the HTTPS protocol's requirements for communication. In order to request the contents of the page, the browser first sends an HTTP request to the server. A request line, headers or request-related metadata, and a body make up an HTTP request. The server can determine what the client, in this case, your browser, wants to do using the information in the request line. The following is in the request line: a request method, which might be one of the HTTP verbs get, post, put, patch, delete, or a few others. A path pointing to the requested resources, and the HTTP version to use. The URL request's request line has the following format: get/dictionary HTTP 1.1. The request line tells the server that you want to get resources at /dictionary and to communicate with HTTP 1.1. Remember that your request's semantic intent is expressed via the HTTP verbs. In order to produce new data or edit current data in the request path, you can also send data to the server using the post, put, or patch methods. The resource at the specified path would be deleted by the delete method. It's crucial to understand that servers are not required to accept all verbs. When a delete method is used, a server could simply return a 200 OK result without doing anything with the requested resource. The request headers come next in the request. Headers assist with route requests, identify the type of client making the request, the user agent, and support UP testing, blue green deployments, and canary deployments by passing additional information from the client. Key value pairs for headers look like this. The last part of the request is the body. The body is usually empty for a GET request like ours. For a request that manipulates resources, like post, put, or patch, the body will contain the data from the client to create or update. The request body can be in different formats, and the server understands the format based on a request header, content type. Here's an example of the full request for the URL, with the request line and headers. Nobody, since this is a GET. Once the server has received the request from the client, the server processes it and sends back a response. 5. Server processes request and sends back a response. The server takes the request and, based on the info in the request line, headers, and body, decides how to process the request. For the request, GET, Donishneru, HTTP 1.1, the server gets the content at this path, constructs the response, and sends it back to the client. The response contains the following: a status line, telling the client the status of the request response headers, telling the browser how to handle the response to the requested resource at that path, either content like HTML, CSS, JavaScript, image files, or data. The status line contains both the HTTP version and a numeric and text representation of the status of the request. The response looks like this. A status code in the 200s is regarded as successful by the browser. The browser knows to render the response because the response code was 200. Resources can be static files that include text or non-text data, such as logo, img or index.html, but static files aren't usually requested by browsers. There is frequently no file attached to these resources because they are frequently dynamic resources created at the moment of the request. In this request, that is in reality what is taking place. Although there is no file named about us, the server is still able to handle the request. In order for the browser to render the page, the server creates a dynamic resource, creating the HTML from templates or fragments and mixing it with dynamic data. Now that you know how the server builds the response to send back to the browser, let's take a look at how the browser handles the response. 6. Browser renders the content. Once the browser has received the response from the server, it inspects the response headers for information on how to render the resource. The content type header above tells the browser it received an HTML resource in the response body. Lucky for us, the browser knows what to do with HTML. The first GET request returns HTML, the structure of the page. But if you inspect the HTML of the page or any web page with your browser's DevTools, you'll see it references other JavaScript, CSS, and image resources and requests additional data in order to render the web page as designed. As the browser is parsing and rendering the HTML, it is making additional requests to get JavaScript, CSS, images, and data. It can do much of this in parallel. In this image, you can see the HTML references a CSS resource. The browser makes a subsequent request to the server to get this CSS resource to style the page. The content type header of the request for the CSS resource tells the browser to render CSS. If the browser requests an image resource, the content type header tells the browser it is non-text data and to render it accordingly. Congratulations! You've successfully traced a URL request from your browser all the way to the server hosting it and received its response back for rendering. Throughout this process, we explored the intricate relationship between websites, servers, and IP addresses, and delved into each step your browser takes when you enter a URL and hit enter. Let's quickly recap those 6 essential steps. You enter a URL in your browser and press enter. The browser searches for the IP address associated with the domain. The browser establishes a TCP connection with the server. The browser sends an HTTP request to the server. The server processes the request and generates a response. The browser renders the content received from the server. Understanding what occurs behind the scenes when you interact with a URL can prove immensely helpful in troubleshooting issues, identifying performance bottlenecks on your website, and ensuring a secure user experience for your visitors. If you are a programmer, do check out the other videos in our channel. See you until next time. Bye.